So for equilibrium, when it has to do with equilibrium, we always make an assumption that, let's say this is a meter rule or any object, we always make an assumption like, let this be the pivot or fulcrum. This is the pivot or fulcrum. Let's say the angle made with this is somewhere here. There is an angle. Now, if you have to apply force on this, maybe something sits here and this has to turn. As it sits here and tries to turn this, this is the force. As this thing is turning, notice that it's going away from this angle. And I told you that away from the angle is sine. So that means that as it's turning, the angle it will be making with this at this point is sine theta. So that is why you normally see that F here will be FR sine theta. And how do you know? Now, how do you now know that like this is dot or cross? Whenever you see sine in cross products or in physics, sine to any quantity means that that quantity is a cross product. So this is the sentence saying F cross R. That's the relationship sine theta. That is what torque is. But assuming is work done, you know that work done is Fs cos theta normally. So the minute you see this cos theta, you should know that the relationship between this F and S is dots S. That is a case where they give you vector questions and you have to solve. So the reason why we always say that torque is Fr sine theta is because if you take it that the pivots is anywhere around that particular object, for that object to turn, it will have to move away from the angle, to move away from the pivots, and the angle of the pivot will be opening. As the angle of the pivot is opening, that means it's forming sine theta. So for that reason, we'll come and put the angle. We now say that that's the angle. So and check something. If I have this and I have this, then I have maybe somewhere here an angle here. It's okay for me to say that these two angles are the same. Yes, it's okay for me to say that the angle here is the same angle here. Yes, alternate angles, they are alternating. So I can say that the angle here is the angle here. So let's prove it. So see, let's say that I have this and this and this, and I have here to be 100. Angles on a straight line, this side to be 80. You can very well see that if you check, the angle here will be 100 because vertically opposite 100, and the angle here will be 80 degrees. Now check it on this other side where you have that thing. If you see it, you see that this angle will be 100. Corresponding angles, they are corresponding. So, and if you check the relationship, they are corresponding angles. Corresponding angles. And if you check the relationship between what we've done here, this thing now, you will see that the angle between these two is more like a situation where if you have this now, if you have this and you have this and you have this, then up here, let's say this is it, that angle. So up here you have this and you have this. So you can very well see that the angle here is the same angle here, and that's the angle made with the pivot. So that is why we normally say that for torque, it is simply Fr sine theta. Thank you.